Okay, hello. This is a simple experiment to teach you how to use an oscilloscope using a potentiometer and an encoder to look at analog and digital signals. So we're going to be using some VEX parts for today's lesson. So the basic circuit you're going to build looks like this. You're going to need some kind of bracket to hold the potentiometer and the encoder on the other side. You want to be able to spin this square shaft and rotate both at the same time. That's the critical part of this. The next thing is getting these signals to the circuit board, the breadboard here. The potentiometer just has one wire with a red and a black and a white wire. The red one goes to power on this power rail. The black one goes to return on this power rail here. Both of these are going to the power supply, which I'll show later. The encoder, you only need one of the two quadrature signals. So we're going to leave one disconnected, and we're going to connect this one to the breadboard here. Same thing, the red wire goes to the positive power rail, the black wire goes to the negative power rail here, and the white wires on both of these sensors go to the scope probes. Now I have this yellow one, which is channel 1, this pink one, which is channel 2, and we'll take a look at how the scope is set up. Okay, let's quickly look at how the power supply is set up here. We have a 3-channel power supply here. We're only using the first channel. We have the voltage set to 5 volts, and we have the current limit set to 100 milliamps here, which is more than enough for these two sensors. And we're going to turn the output on so that we power the sensors. And that should be all you need to get a signal out of the sensors into the oscilloscope. So now the more interesting part, how do we set up the oscilloscope so that we can capture the signals? And what I have on the screen here is basically what we want to see at the end of the day. We have channel 1 showing the potentiometer output. We have channel 2 showing the encoder output. Now, one of these is an analog sensor and one is a digital sensor. Hence, one has a smooth line from the minimum value to the maximum value. And the other one has a bunch of square waves corresponding to ticks at a specific angle that you rotate the encoder. So I'm going to walk you through setting up this power supply. So let's walk through setting up the oscilloscope. First thing I'm going to do is say auto setup just to get to a starting point. As you can see, we don't really have much going on here. So first I want to set up my channels. We're going to use channel 1 and 2. So channel 2 is selected already. I'm going to press 1 so that I can turn on channel 1. Now you see a yellow and a pink line. If I move the position of one of these up, you can see there's 2 lines here. So channel 1, the 0 for that is this triangle here, the yellow one. If I click channel 2, the 0 for that is actually off the screen right now, but it is this pink line. Okay, so we need to set up the voltage scale and the 0 reference position so that we can see both of the signals clearly on this screen. So to do that, I'm going to mess with this voltage scale knob and the position knob. And we don't really know what the signals are ahead of time, so I'm going to give you guidance on what to set these two to get pretty close. So what I want to do is I'm going to set both of these to about 2 volts per division. Okay, I'll click on channel 2 and do the same thing. Okay. Now I want to bring these somewhere on the screen that I can see them. So I'm going to position channel 1 zeroed basically in the middle of the screen, and then channel 2 I'm going to put somewhere on the bottom half of the screen. It's way off. Okay, so I'll bring that right around here. Okay, so now I know that we have the entire signal displayed on the screen with this scale. Next, we're going to look at the time scale and the horizontal axis. This one I want to set to something pretty slow so that we can capture you rotating the shaft by hand at somewhat a reasonable pace. So we're going to zoom way out here. We're going to go all the way to 500, nope, wrong way. We're going to go all the way to 500 milliseconds per division. Okay. So now that's pretty close to what the settings need to be. I want to be able to just look at the signals as they're being captured, not one screen at a time. This acquiring scroll bar basically means that it's capturing data one screen worth, and then it will update it once this is full. But I want to see it in real time. So we're going to press this roll button. What this does is roll the signals across the screen in real time. Okay, and so now we should be able to rotate the encoder and potentiometer shaft by hand, and I should be able to see the signals change. Okay, you see there, let me move the camera. You can see what I'm doing here. All I'm doing is rotating this by hand. Okay, and as I do that, you can see channel 1 and channel 2 will change. So what I want you to do is start all the way on one side, doesn't matter which direction you go, and then try and be steady and rotate from one extreme of the potentiometer to the other. So I'm just going to sweep across it. Okay, and then I'm going to hit stop before that rolls off the screen so that I can take a look at that. Now we have the potentiometer signal and the encoder signal. And as you can tell, the potentiometer signal is a voltage, it's an analog voltage, and it goes from this voltage up here all the way down to this voltage at the two extremes of its travel. The encoder could spin more than we're allowing it to. It can rotate continuously, but at every certain number of degrees, you're going to get one tick out of it. And what I want you to do, you can zoom in and out now on the time scale if you want. I want you to count how many of these square waves there were from the start of the travel to the end. Okay? This number of ticks divided by the number of degrees the potentiometer can rotate. You can measure that with a protractor or just eyeball it. Divide that angle by this number of ticks, and that will tell you the number of degrees per tick. So if you zoom in, this is going to be some number of degrees every time it goes up and down. And I want you to tell me what each one of these lines going up or down corresponds to in terms of degrees. Now you can see this is not all the same width. That's because I wasn't spinning the shaft smoothly at a perfectly uniform speed. So as my hand slows down and speeds up, you're going to get different widths. But that's not really important for this lesson. You just need to count the number of ticks that there are. Okay. So the final thing I want you to do, zoom back out here. So I want you to tell me how many volts this potentiometer sweeps across when you go from one extreme of the travel to the other. And the way you do that is going to use these cursors. Okay. And you can set up the cursors to be on the x-axis or the y-axis. So if I put x, I can move this in the x direction. If I say y, I just click that, I can move this up and down. Okay, so I'm going to put 1 at the bottom here. And then if I click this round button, I can move the other cursor. Oh, that moves it together. So one more time, and I can move the top one separately. It doesn't have to be exact, just ballpark. I want to read this delta y, which is y1 minus y2. So from one extreme to the other, I get about 3.8 volts of change in the potentiometer signal. Okay, which is good because it should be less than 5 volts, which is what we have the power supply set to. All right, so that's what I want to see. I want this plot. I want it annotated with these voltages. I want you to tell me how many degrees this ends up corresponding to and how many ticks there are. And that is it for today.